This question gives us a formula for compound interest. A equals P times 1 plus little r over n raised to the nt. A is the amount of money in the account, P is the initial investment or principal, R is the annual interest rate, N is the number of compounding periods per year, and N is the number of years. And then if interest is compounded continuously, we have a different formula. We have A equals PE to the RT. And then our first question asks if the initial investment was 1,000, so that's P, so P is 1,000. Paying 3% annually, if that's the case, little r is 0.03. 3% converted into a decimal is 0.03. Compounded monthly, so how many periods per year? If it's compounded monthly, then n is 12. And for a total of 10 years, so t is 10. So we have all that information. We want to find out how much is in the account at the end of those 10 years. So I've got all that information. Let me go ahead and plug that in. So A equals P, 1,000, times 1 plus R, 0.03, divided by N, divided by 12, raised to the N times T, 12 times 10. So I'm going to want to do this on the calculator, of course, but let's see if we can simplify it a little bit. 1,000, 0.03 divided by 12 is 0.0025. Raised to the 12 times 10, raised to the 120. So we get A is 1,000. 1 plus 0.0025 is 1.0025. Raised to the 120. So we'll do this on the calculator, which is certainly easy enough for us to do. And we have 1,000 times 1.0025 raised to the 120. And we get 1349.35. We'll round that to the nearest penny, 1349.35. Now I want to show you, I could have done the whole thing from here on the graphing calculator. It's a little trickier. I'll show you how to do that as well. So it'll be 1,000. You've got to really keep in mind the order of operations. 1 plus 0.03 divided by 12, parentheses, raised to the, and the way this calculator works, I'm not going to have to worry too much about order of operations. 12 times 10. It's putting it up in the exponent automatically for me. Other calculators may not. And then hopefully it'll give me 1349.35, and it does. Very good. So that was for compounded monthly. Now, what was the next question that we asked? If the initial investment was 1,000 in an account paying 3% annually, compounded continuously. So consumers always think, oh, the more often interest is compounded, the more money I'm going to make. And there's some truth to that, but you'll see that the difference is not as great as you would think. Compounded continuously means more than every second. And then the model we have for that is A equals PE to the RT, as you see here. Again, what do we have? Our principal P is 1,000. Our interest rate R is 0.03. And our time factor here is, again, is 10 years. So we're going to plug that into our formula. A equals PE to the RT. So again, I get P is 1,000, R is 3%, or 0.03 in decimals, T is 10 years. So A is P, 1,000, E to the R, 0.03 times 10. So we'll go to the graphing calculator to do that. And we'll see what we get. 1,000 E to the is second natural log. You'll see it a little bit in blue. E to the 0.03 times 10. I think I can do it this way with the order of operations. It'll leave it in the exponent on this version of the calculator. And how does it compare to 1349? I need 1,000, not 10, excuse me. So we'll go ahead and we'll adjust that. Second insert. 1,000. And then delete these guys. All right, so now I have 1,000 e to the 0.03 times 10. How is it going to compare to 1349.35? What do I get? 1349.85. So the difference between compounding once a month and compounding every millisecond, or even more often than that, is a whopping 50 cents. So being concerned about how are 51 cents if you want, 1349.86, I guess, if I round it to the nearest penny. So get a better interest rate. That's more important than concerning yourself with how often it's compounded. And then we have one more question here. What does it say? If the initial investment was $1,000 in an account paying 3% annually, compounded continuously, how much time must pass before there is $1,500 in the account? So what do we know? The initial investment, P, is 1,000. Paying 3% annually, R is 0.03. How much time must pass? Find T when there is 1,500 in the account, when A is 1,500. And again, this is compounded continuously, which makes this a lot easier for us to work with. So we're going to go with A equals PE to the RT. A, 1,500. Equals P, 1,000. E to the RT, E to the 0.03 times T. We want to solve for T. We're going to first divide both sides by 1,000. Divide this side by 1,000. Divide this side by 1,000. 1,500 divided by 1,000 is 1.5. Equals E to the 0.03t. To pull the exponent down, we need a natural log. Natural log 1.5 is natural log e to the 0.03t. Natural log 1.5. The exponent 0.03t comes down in front is 0.03t times the natural log of e, but the natural log of e is just 1. So I get natural log 1.5 is 0.03t times 1. Then divide both sides by 0.03. We get t is natural log 1.5 divided by 0.03. We'll take a look at what that looks like. On top, natural log here, 1.5. Divided by 0.03. I think my order of operations here are good, and I get what? I get 13.5 approximately. So 13.5 years is what it's going to take to do that. So what was the question asking, right? We started with 1,000, getting 3% annually. How long will it take to get 1,500? Well, if that's the case, it'll take a little bit more than 13.5 years for that to happen. So it takes 13.5 years. 13.5 years about to reach $1,500 in the account. Now we can try to solve this on the graphing calculator. Remember, here's our question. 1,500 equals 1,000 e to the 0.03t. Let's subtract the 1,500 from both sides. So 0 is 1,000 e to the 0.03t minus 1,500. And I'm going to go ahead and solve it on the graphing calculator using the zero finder. My function y1 will be 1,000 e to the 0.03. I've got to use x, though, instead of t because of the calculator syntax. And I'm going to find out where is the zero of that function. So let's try it. To the calculator we go. And we'll go 1,000 times e to the, which is here, 0.03 times x, 0.03 times x, and then minus 1,500. Minus button is here. And I expect it to happen around 13.5, so my window's got to at least go, another zero for 1,500. My window's got to go beyond 13.5, so maybe I'll go to 25. But I think I need a whole lot more y values just to kind of see this grow. So I don't know, let's try something and we'll verify it from there or change it. Maybe negative 400 to 1,000 on the y. By 100, we'll see if that's good enough. I'm looking for the zero of the function. Can I see anything here? Let's take a look. Where does it cross? Yeah, that's pretty good. I picked a good window. So I want to find the zero of the function. Remember what I was trying to do, right? We wanted to find when does 1,500 equals 1,000 e to the 0.03 t. I said subtract 1,500 from both sides. Find out when this function equals 0. So that's where I'm at. So zero finder, second calc. Find the zero, which is number 2. Move the cursor a little bit to the left of where it crosses, which is about here. Bing. A little bit to the right where it crosses, bing. Where it crosses, moving pretty close, bing. And I expect it to be about 13.5. Is it? 13.5. Feel good? 13.5 years for it to grow to $1,500.